Exercise 1.2 problem 5 solution. So let the universal set U be 4, 8, 12, 16, 20, 24, 28. Set A equals to 8, 16, 24 and set B equal to 4, 16, 20, 28. Find A union B whole complement and A intersection B whole complement. We'll do by both normal method as well as by Venn diagram. Okay, for normal method we don't need to worry about anything. We can straight away start operation. To find A union B whole complement, how will you do? You'll first find A union B, then find A union B whole complement, which is nothing but we'll have to remove the elements of A union B from the universal set, or whatever is left over in universal set after removing A union B is A union B complement. Complement means that whatever is complement that needs to be removed from the universal set. Okay, so now let's do the A union B. So we need to combine A and B. So combining, what will you get? You'll get 4, 8, 16, 20, 24, 28, right? So that is what is written here. 4, 8, 16, 20, 24, 28. I have done this way, but now another way of doing it, right? These two elements, these to combine these two sets, but be careful not to repeat elements, okay? Then arrange them in a particular order, in a descending, ascending or descending order. I've skipped that step, but I think it's not advisable. In the next version, I'll correct that. Okay, and this is very good chance of making mistake in this method. Now, okay, leaving that. Now, A union B we have found. A union B whole complement is, you'll have to remove all the elements of A union B from universal set, and whatever is left behind is A union B whole complement. Okay, so that is 12. Now, how do we do? So, 4 is cancelled. Okay, 4 is cancelled. 8 is cancelled. 8 is there in A union B. 16 is there. 20 is there. 25 is there. And 28 is there. I have marked all these elements here in this universal set. So, what is left behind? Left behind is only 12. So, A union B whole complement is 12. Okay, now let's try to do this by Venn diagram as well. But for Venn diagram, first thing we need to find out what is intersection of A and B. Do we have any intersection? Yes. 16 is intersection. So we have to draw two circles A and B, intersecting circles in a rectangle U. Okay. So two circles A and B is drawn with an intersection, and we know the common element is 16. Put that 16 here. Now what is left in A? After removing the intersection, 8 and 24. So that will come in this area. Similarly, what is left in B is 4, 20, 28. That will come in this area, right? That is B minus A. So this area it will come. And any element in U which is not covered, yes, 12 is not covered in all these two sets. So that 12 will come out of A and B. Okay. First we put A intersection B, then we put A minus B, then we put B minus A. Then you'll have to put the element which is not covered in A and B. So if you see, 4 is covered in A, 8 is covered in B, 12 is not covered, 16 is covered in A and B, 20 is covered in B, 24 is covered in A, 28 is covered in B, right? You can check it here. So that is why only 12 is left out. So that 12 will come out of A and B, but inside the rectangle, because it is part of the universal set. The rectangle represents the universal set. Now we have put the Venn diagram. Now we need to find A union B whole complement. That is, this is A union B, right? You can mark it. Okay, so this is A union B. So what is the number out of these two, or element which is out of this marked area? That is 12. So A union B whole complement is 12, and that is what we got by this method also, normal set operation method. So both ways are right, whichever you are convenient, but I think it is much easier and faster to do the normal method. Okay, unless they specifically say use Venn diagram. Okay, now let's do the next one. So next one is A intersection B, because you are asked to find A intersection B the whole complement. So first we need to find A intersection B, and then you have to find A intersection B whole complement. We know A intersection B, the common number between these two, or a common element, is 16. So A intersection B is 16. Now remove 16, that all the other elements are, that is 4, 8, 12, 20, 24, 28 is A intersection B the whole complement. Right? We write all the elements of universal set other than in A intersection B. So it's 4, 8, 12, 20, 24, 28. Now let's try to do this in the Venn diagram. The same thing. So what is A intersection B? This area, right? Which is 16. So what is A intersection B complement? All the other areas other than this marked area, right? All the other areas, we'll have to leave out this marked area. So marked area is 16. So you can take all the elements out of this marked area, that is A intersection B whole complement. Now which will be 4, 8, 12. Okay, I'm telling it in the order. That's all it is. 4, 8, 12, 20, 24, 28. 4, 8, 12, 20, 24, 28. Which is the same. So both methods gets you the same answer. But if time is short, go by this method and don't use this method unless otherwise they have specified that use Venn diagram. Okay, but for completeness, I'm showing both the Venn diagram as well as a normal method. Okay, thanks for watching this video.